And finally, we have come to the last exercise, number 16. Here we have a metric space X and the metric is D, and there are two sequences xn and yn. In X, xn converges to a point X and yn converges to a point Y. Both the points are in X, of course, with respect to the metric D. Then we have to prove that this sequence D of xn comma yn, that is the sequence of the distances between xn and yn, the corresponding terms of these sequences converges to the distance between x and y. Note that unlike these original sequences, which are sequences in the space X, whatever the space is, this is a sequence of real numbers, because each term in this sequence, as you change the n, you are going to get the terms of the sequence. Each term is a real number, and that too a non-negative real number, because these are distances, and this is also a real number. So let's see the solution. The solution, as usual, starts by considering an epsilon, which is any positive real number, and then we are immediately going to use the fact that these sequences converge respectively to these points x and y. So for this epsilon, we are going to get two positive integers, capital N1 and capital N2, such that the distance between xn and x is less than or equal to epsilon divided by 2 for all n greater than or equal to n1, which is happening because of the first sequence converging to x, and the distance between yn and y less than or equal to epsilon over 2 for all n greater than or equal to n2, which is happening because of this convergence, this sequence being convergent to y. So next we consider the maximum of these two positive integers n1 and n2 and say that is capital N. Then for any integer n greater than or equal to capital N, let's see this calculation. We start our calculation with the distance between xn and yn, where the suffix n is same. Using the triangle inequality in the metric space 2 times, this distance becomes less than or equal to the distance between xn and x plus the distance between x and y plus the distance between y and yn. If you want, you can write another step here in between these two steps. So what you do, first in place of this distance d of xn comma yn, you write d of xn comma x plus d of x comma yn, and then you apply triangle inequality once more, and that's how you get these other two distances. So by two applications of triangle inequality, we are getting this. Now you look at what this index n is. N is greater than or equal to capital N. So n in particular would be greater than or equal to n1 as well. But when that happens, then d of xn comma x is less than or equal to epsilon divided by 2. So if we replace this distance by epsilon over 2, then we have the inequality, and we keep this one as it is. And again, because n is greater than or equal to n is also greater than or equal to n2. So this second inequality is also true for that small n, that d of y comma yn comma y is same because of symmetry. So this will be less than or equal to epsilon over 2 as well, and that's how this becomes epsilon plus d of x comma y, and then you subtract d of x comma y from both sides of this inequality, that this is less than or equal to this, and that's how you get this. D of xn comma yn minus d of x comma y is at most epsilon. Similarly, for this type of n, you also have this other inequality, where this time instead of this difference we have the other difference, where we see d of x comma y first and then d of xn comma yn. That is also less than or equal to epsilon. How? Well, you just again go through these steps, but now you start with d of x comma y. and then gradually like this you bring d of xn comma yn into the picture. That's just similar to this one. Okay, so I leave that part to you. So then what are we seeing here? We are seeing that d of xn comma yn minus d of x comma y is less than or equal to epsilon, and its negative is also less than or equal to epsilon. So obviously the absolute value of this difference is going to be less than or equal to epsilon, because the absolute value is either this or this, depending on which one is greater and which one is smaller. But then what are we getting here finally? That for our chosen epsilon in the very beginning, there exists a positive integer n such that the distance between these two real numbers, one of them is d of xn comma yn, which changes depending on n. As n changes, it also changes, and the real number d of x comma y, which is fixed, is less than or equal to epsilon for all n greater than or equal to n. But that just simply means that this sequence, whose nth term is d of xn comma yn, this sequence of real numbers converges to this real number, and that's it. And with this section is finally complete. In the next section we are going to study topology of metric spaces, which is a very interesting one. So next week we are going to see that. So see you next week with those things. Until then, this is me, Lucifer, from a mathematical group. Have a nice day.